What we want to do is we want to be able to find an equation of the tangent line to the parabola y equals x squared at the point 1, 1. So if we investigate here, we can see that this represents the point 1, 1. Okay, so we'll go ahead and then plot that on our graph, point 1, 1. Okay, and now what we want to do is we want to be able to find an equation of the tangent line t, okay, as soon as we know its slope. Okay, but before we do that, all right, we need to pick some sort of arbitrary point here or anywhere on that curve. Okay, so I will go ahead and label these 2 points, this line, it'll just be green here. Okay, now the green line, okay, is intersecting the graph at 2 points. Okay, now remember that the definition of a tangent touches it once. So when it intersects the graph more than twice, we call this a secant. Okay, now the difficulty is that we know only one point in this scenario, which is 1, 1. Okay, now whereas we need 2 points to compute the slope. But since we have our equation, okay, y equals x squared, then we can arbitrarily say that this point, we can call it q, and if the input would be x, well then the output, which is the function x squared, would be x squared. So now what we have is we've determined 2 specific points. Okay, now in this scenario, we want to be able to find out what is the general slope formula, meaning like what is the slope of PQ, because that's what we want to find. We want to find the slope of PQ. So I'm going to go ahead and write down the general form for that. So we got to use our slope definition. So remember that's y2 minus y1 over x2 minus x1. So y2 in this case is x2, and then we're subtracting y1 all the way over x2 minus x1. So therefore that is our general, okay, slope form for this particular equation. Now we have to make sure that x does not equal 1, because in this scenario it would make it undefined. Okay, and we also need to make sure that q would not equal p. Okay, so again, that is our generalization of this particular equation. Now, if you notice here, this is where the value of 1 is located. Okay, and so we have values that go in between 0 and 2, but it keeps going because this is our x-axis and this is our y-axis. Now, what we want to do is, since we know the point is 1, 1, and it's starting at 1, we want to figure out, okay, from the left side, we're going from 0 to 1, and then from the right side, we're going from 2 to 1. So what's happening here? Well, what we can do is we can pick values in between 0 and 1, and pick values in between 1 and 2, and then determine what's happening with the slopes according to this point 1, 1, since that's what's given. So if we take the value of 2, okay, and use that as our first point of x. Okay, let's go ahead and do that. We're going to let x equal 2. Okay, now if we plug that into our function, then that means that y would equal 2 squared, which would then be 4. Okay, so now we know that we have this ordered pair 2, 4. And what we're going to do is we're going to compare it to the slope with our 0.11. So let's go ahead and do that. So for the first one, we want to be able to find the slope when we pick 4 to be y2 and 2 to be x2. So we end up with 4 minus 1 over 2 minus 1, which gives us 3 over 1, which is equal to 3. Okay, now as you can see up here, okay, when the value of x is 2, we determined that the slope equals 3. Now, let's go a little closer to 1. So as we're going closer to the point 1, we're moving now inward. Okay, so the number in between 2 and 1 is 1.5. So similarly, okay, if we want to use 1.5, okay, we'll go ahead and do the same thing here. If we choose x to equal 1.5, then we know that when we substitute 1.5 in for x and then square it, okay, it's going to give us a value of 2.25. So now, to find this slope, we're going to use those points. So we got y2 to be 2.25. So we have 2.25 minus 1 over 1.5 minus 1. Okay, and then what that's going to do is that's going to give us a slope of 2.5. So again, you can see here in the next one we get 2.5. Okay, now you should be able to see the pattern now for what's happening. Okay, again, if we choose 1.1, okay, let's go ahead and do that. So if we let x equal 1.1, and then we're going to pick y to equal 1.1 squared. And again, 1.1 squared gives you 1.21. So now we're going to use the order pair 1.1 and then 1.21. Okay, so now we're going to find the slope of this. And so we end up with 1.21 minus 1 over 1.1 minus 1. And now we're going to get a slope of what? 2.1. Okay, so as you can see, if you look here, as x, okay, gets closer and closer to 1, the slope is getting closer and closer to what? 2. Okay, now let's look at this other table here. Okay, so again, this is going from the value of 2 approaching the value of 1 because 2 is going to 1. Now what happens on the other side when we're going from 0 to 1? Okay, well let's take a look at that. So now if we look at this table here, okay, and we're going to let x equal 0. So if you plug in 0 for x, then y is going to be 0. So you're going to have the ordered pair 0, 0. So let's find a slope of that. So finding the slope using those 2 points is going to be 0 minus 1 over 0 minus 1, which gives you a positive 1. So you can see what happens with the slope when the value of x is 0. Okay, and let's do one more. Okay, let's see what happens when it's equal to 0.99. So when x is equal to 0.99, okay, y is going to equal 0.99 squared, which is 0.9801. Now again, finding the slope of that, you get 0.9801 minus 1 over 0.99 minus 1. And then that's going to give you a slope of 1.99. So what it's saying here is now is that as x, which starts at 0 and it gets closer and closer to the value of 1 on the left side, okay, then the slope then eventually is becoming 2. So what that means is that we want to be able to find a line, okay? Now, hopefully my line shows it a little bit better, but we want to make sure that it touches, okay, the graph once. Now remember, when it touches the graph once, that's going to tell us that it's tangent to that line. Okay, so what we've determined from making our tables is the fact that our slope is equal to 2. So by looking at those two tables, it's approaching 2. So we can say that our slope is approaching 2. Okay? And then what we're going to do is the given point was 1, 1. So now that we determined that it's approaching the slope of 2, then we can use our point slope form to find the equation of that line. So we'll have y minus 1, which is equal to 2 times x minus 1. And then solving for y would give us y is equal to 2x minus 1. And therefore, this is the equation of the tangent line through 1, 1. So let's take a look at Desmos here. This is the equation 2x minus 1. And so what I've done is, okay, I've graphed the parabola x squared. Okay, and what we want to do is, let's see what happens when we graph. Hopefully it allows us to do that here. So we're going to graph 2 x minus 1. And so now what you can see here is that this graph is intersecting and it's a tangent, so it's touching only once on this parabola. All right, so let's move on to the next illustration. Now before we move on, I want to show you an animation.